makers! Today we're going to learn about some different kinds of circuit structures, and to do that we're going to use our new component on the bench, which is the buzzer. Our buzzer module has this black cylinder on top, and inside that is a film. The film vibrates when a current is applied, similar to when you blow on an instrument with a reed. Our buzzer module is also polarity sensitive, which means it has a positive side and a negative side. On page 14 of our notebook, I'm going to fill in the traces on the first diagram, and we'll give a listen to our buzzer module. If I look under my battery, I can see the recommended polarity, positive on the top, negative on the bottom. If I look under my buzzer, I can also see recommended polarity, positive on the left, negative on the right. With the buzzer in this orientation, and I turn my circuit on, it works. If I flip my buzzer around and turn the circuit on, it doesn't work. That's because it's polarity specific. If I replace my switch with my dimmer module from before, if I turn my circuit on, when I increase the resistance on my potentiometer, you can hear the pitch and the volume of my buzzer go down. This is because with a higher resistance, there's less current flowing through my buzzer, which gives us a lower volume and a lower pitch. If we make another substitution and replace our dimmer module with the LED, when we turn our circuit on, we can hear that our buzzer is not quite as loud as it was with our switch. We can verify that by putting our switch back in. Hear the difference? This is because our LED module has resistors inside it. You can see on the circuit diagram, on top of it, that little symbol right there, that squiggly thing, is the symbol for a resistor. So it has a resistor wired on the red side and on the blue side. The circuit I'm drawing is a parallel circuit. In a parallel circuit, our current has two paths that it can follow, as opposed to our circuit we were just using where we only had one path. If I turn on my battery module, I can hear my buzzer and see my LED. As opposed to my previous circuit, the addition or removal of the LED had no effect whatsoever on the volume of my buzzer. Let's take a closer look at series versus parallel. To do that, let's get out our blue cardstock and draw some custom circuits. This is a parallel circuit, and this is a series circuit. To get a better idea of what our LEDs look like, we're going to dim our lights. If we turn our circuits on, we can see that our parallel circuit is quite bright. Our series circuit, on the other hand, is not as bright. What happens if we add another component to each circuit? If we flip our circuits on again, the parallel circuit has not changed. The LEDs are just as bright as they were before. In the series circuit, it's gotten even dimmer. Why is that? Well, in our series circuit, every time the current passes through another LED, the voltage drops. Let's illustrate that with our multimeter. This time, we're going to set our multimeter to DC volts to analyze our circuit. The voltage supplied by our battery in our parallel circuit is 8.5 volts about. The voltage across the first LED is around 8. The voltage across the second LED is slightly less than that, pretty close to 8 though. The voltage across the third LED is around 7 1/3. The voltage across the fourth LED is also around 7 1/3. The voltage across each of my LEDs is relatively similar. The difference is actually due to the ink on our paper that we drew. In comparison, let's check our series circuit. The voltage across our first LED is 2.225. Across our second LED, again, we have about 2.2. Across our third LED is 2.2. And across our fourth LED is 2.2. On this side, the voltage supplied by our battery is around 9 volts. If we take 9 volts and we divide it by 4, we get about 2.2. Let's go back to our 3 LED circuit and check our voltage. The voltage across this LED is now 2.9, or just about 3 volts. Again, we have a 9-volt battery with 3 LEDs, so 9 divided by 3 is 3. Another interesting property of these two circuit configurations is in a parallel circuit, if you pull out one of your components, the other components stay on. You can pull out lots of these components and the other ones stay on. In a series circuit, if I pull out a component, they all turn off. That's because in our series circuit, there's only one path for the current to follow, and in a parallel circuit, there are multiple paths that the current can follow. Make sure to keep the properties of parallel and series circuits in mind when you're building your own custom circuits. If you have a lot of components and you want them all to stay on, you might want to use a parallel circuit. If you use a series circuit, you might run out of voltage. Thanks to Scribe for sponsoring this series of educational videos. All of the components in this video are for sale on the Scribe website. Use code BerbawyMakers to get 15% off. Also on the website is troubleshooting help if you're having trouble with your pen or any of the components, and you can sign up for their live classes. I'm Ms. Berbawy. Tune in next time to learn how to control RGB LEDs.